Okay, part 7, make sure I get these right. We're going to look at this, and our intercepts that we did in the last segment. So let's start with an equation. This equation could mean anything. It could be part of a growth line or a decline line. It could be part of anything. But let's say that I've given you something like this. And I'm hoping that you kind of almost see that this you see how that is very similar, is pretty much that? You see how this and this are pretty much what the variables are? C is 15, B is 3, A is actually a negative. So that comes from what this is. So this means this is also that linear equation, just in disguise. So I want us to play around with this for a little bit. So the first thing is that remember our intercepts? So what if I'm given this graph and I wanted to find out some information about this graph. So let's look at what if we let x be 0. Do you remember when we let x be 0, what do we find? So if we so down here, if we let x be 0, we have the y, intercept. Well, remember if we let y, we find x intercept. Okay. So we're finding these intercepts now. So if we let x be 0 for our equation, where is that going to be? Well, it's right there. So you're going to do this. You're going to go -5 parentheses plus 3y equals 15. And what are you going to put right there for your x? You're going to put in 0. You're going to put in 0. And the reason you're putting in 0 is because you're trying to find where does the graph, or does this line in disguise, hit the y-intercept. What's our starting point? So if you let this be 0, what's -5 times 0? 0, correct? So you have technically this, because that's gone. How do you solve for y? Well, remember you divide. You get 5. Okay. Now, let y be 0. So if you let y be 0 for our same equation, what are we solving for? We're solving for x now. So when we let y be 0, we're solving for x. So let's make sure we understand this. And so -5x plus 3y equals 15. I'm just rewriting the equation again. But this time I want to put in what? Y equals 0. So at -5x plus 3 parentheses 15. What am I putting in here? I'm putting in 0. Because I'm trying to get the x by itself. So, line 15, negative 5x. Do you remember how to solve for x? Divide, divide. This goes away. If x equals positive divided by negative, negative 3. So, you just found two pieces of important information about this line right now. You found where it intersects. So, back up. This is what we're doing. So let's do this. Remember our t-table? Remember we have when x is 0, what do we get for y? When x is 0, what do we get for y? 5, right? When y is 0, what do we get when y is 0? Negative 3. So, this right here tells me a lot. This tells me, this right here tells me the y-intercept. So, this tells me the y-intercept. This right here tells me the x-intercept. Okay? So if we were to graph this, x and y, 0, 5. So we have 1, 2, 3, 4, 5. There's the y-intercept. Negative 3, 0. Negative 3, 0. There's our line. There's our line. And that is what we're trying to graph. We're trying to graph this equation from our intercepts. Where does it intercept the x, the x and the y? So, what if we wanted to find the slope of this line? The slope. So now, erase this. So now, what about the slope? What about the slope? How would we find the slope from this graph? There's two ways we can do this. One, we can solve for y, and we should get b. We can solve this for y and get b. Or, if we have a piece of graph paper and you have a nice graph, you can actually go rise over run, rise over run. It's really up to you how you can do this. But here's probably my suggestion. And this suggestion should work. So let's take our graph, our equation. That's our equation. And solve for y. Boom. What do we bring over to get y pretty much all much by itself? Correct? Correct? What do we divide by now? 3. But remember, this 3 has to divide the whole thing. So this goes away. That goes away. Now you have 5x divided by 3 plus, what is 15 divided by 3? How many 3's go into 15? 5, right? So now, look at that. And look at this. What's your slope? Five over 3. So you're saying that this goes up 5. So you're saying that this goes up 5 over 3. Up 5 over 3. Up 5 over 3. And there's your slope. So you just figured out from one equation the intercepts, and the slope. One more time. From one equation, you just figured out the intercepts and the slope. And that's pretty much what that's what we're doing. We're trying to figure out some information to make a somewhat accurate graph that we can without pretty much having our calculators or computers do it. You don't need all that. You just need some numbers, really. It's just some numbers to get you kind of started, and zeros are a way to start. Zero is pretty much the standard point from nothing. You put 0 in, you get nothing right now. And that's kind of, you get this, like the starting point of this. And that's what we're trying to do. So I kind of would like to do some more examples with these. And maybe let's do one more part with a whole bunch of maybe these examples. Do we have to do a lot of graphing? I would encourage graphing a lot because you do get better at the graphing as you get to see the numbers flow. But maybe we can limit to a little bit of graphing next time and try to focus on giving you an equation, figuring out the y and x intercepts, and then figuring out the slope. And those are the 4 pretty much key essentials that I want you to develop in this part series. So I will see you in the next video with lots of examples on this. Have a good one.